Hey guys, welcome back to my videos. Today we are solving a fun Math Kangaroo challenge from 2021 for grade 5 and 6. Let's crack 11 to 20 questions which mark as part B and level up our math skills. Ready? Let's go. Problem 11. A triangular pyramid is built when 10 identical balls as shown. Each ball has one of the letters A, B, C, D and E on it. There are two balls marked with each letter. The picture shows three side views of the pyramid. What is the letter on the ball with the question mark? So this is our full pyramid and these are the different faces of those parameters. Now we need to figure out the number that should go in the place of the question mark. So first, let's visualize the shape on a triangular pyramid. So we can visualize the shape as a triangular pyramid with size A, B, D as it reflects here. ACE, that is this one. And D question mark E bottom. The side face AED, so AED, ABD, ABD. So that is the side face. And the third face ACE, ACE and AED, and this is the face. So at the base we see the balls labeled D, D and E. So it says in question there are two balls marked with each letter. Now let's count. So there are two balls marked B, two balls marked C and two balls marked D and two balls marked E. We only have one ball marked A. So the missing ball, the one with the question mark, must be another A to make it 2. So our answer is option A. Problem 12. There are 20 apples and 20 pears in a box. Carl randomly took 20 pieces of fruit from the box and Luca took the rest. Which of the following statements is always true? And these are our options. Now let us go through each options one by one and see which is our correct answer. Option A. Carl got at least one pear. Not always true. Carl could take all 20 apples or 0 pears. So this is not always true. So this is not our answer. Option B. Carl got as many apples as pears. This is not always true as well. Carl could take 15 apples and 5 pears or any other combo. So this is not guaranteed as well. So option B is not our answer. Option C. Carl got as many apples as Luca. Again, not always true. If Carl took 14 apples, Luca got 6 apples. So apple counts can differ. So option C is not our answer. Option D. Carl got as many pears as Luca got apples. This could be our answer and let's prove it. So if Carl pick 5 apples, that means he is picking 15 pears. So the rest will be picked by Luca. So he is left with 15 apples and 5 pear. So option D says Carl got as many pears as Luca got apples. Carl got 15 pears and Luca got 15 apples. And this option is correct. So our answer is option D. Problem 13. The number 502197290 is written on a sheet of paper. Julian cuts the sheet twice so he gets 3 numbers. What is the smallest sum he can get by adding these 3 numbers? These are our options. So Julian cuts it into 3 pairs like slicing it into three smaller numbers, then he adds those three numbers. He wants the smallest total. Here is the tip for solving this problem. We don't want the largest digit to appear in the first place. Instead, we prefer to keep the largest digit towards the end. So here is our number. According to his strategy, we will start by selecting the segment with the smallest digit in the first place. Based on that, we make our first cut from here. Then we cut from here because 2 is the smallest. So when we add 2970 and 02197 and 5, we get 2715. So we get 5172. That is our option C. So let's see if C is our answer or not. Let's clear our screen. Now let's cut from. So we do 50, 2197, and then we cut before a smallest number. So we got 2970, 2197 and 50. And let's add that. So we get 7, we get 1 here, we get 2, and then we raise and we get 5. So we get 5200. So we already have C as the smallest, so we will eliminate D for now. Let's move on to another cut and see if we can get a smaller than 5172. So we cut from here 512, 1972 and take 970. So we add 1972 and then 970 and 502, and then we add 4, 4 and 4 and 3. Okay, we got a smaller than 5172. This is option B. So option B could be our answer. Let's try one more cut. So we cut from 502, 197 and 2970, and let's see if this is smaller than 3444. So 2970, and then we have 502 and 197. Let's add that. So we have 9, 6, 6 and 3. So we got 3669, which is not smaller than B. So our answer is option B. Problem 14. The map shows 3 bus stations at the point A, B and C. A tour from station A to the zoo and the port and back to A is 10 km long. A tour from station B to park and the zoo and back to B is 12 km long. A tour from station C to the port and the park and back to C is 13 km long. A tour from the zoo to the park and the port and back to the zoo is 15 km long. So these are the measurements given as it's shown in the picture. How long is the shortest tour from A to B to C and back to A? These are our options. So we have to find the distance from A, zoo to B, B to C and C to A. We have been given measurement for A, zoo to port 10, zoo B, park 12 and port park C 13, and in between it is 15. So we have been given the parameters of this shape. So what we have to determine the parameter on the red line and the blue is in the inside. So we know that A to zoo and zoo to port and port to A is 10 kilometers. We also know that zoo to B, B to park and park to zoo is 12. Similarly, port to park, park to sea, sea to port is 13. So I have used the side with the red is coincide with the red lines, the blue with the blue lines. So it will be clear for you. Now we have the fourth parameter given, which is zoo to park, park to port, and port to zoo. That is 15. Now we add these three together. So what we see that there is a zoo port, park zoo, and port park. If we sum together, that is 15. So we can replace these three when we add together these three lines. We can replace with 15. So it will replace like this. So we have A to zoo, port A, zoo B, B park, park C, C port, and the remaining is replaced with 15. We have to sum other side of the equation as well. So we have 10, 12, 13. So we add together, and 10 plus 12 plus 13 gives us 35. Now we subtract 15 from both sides and we get 20. So the length of all the red line is 20. So our answer is option B, 20 kilometers. Problem 15. Three rectangles of the same height are positioned as shown. The numbers within the rectangles indicate their areas in square centimeter. This is our rectangle. It is of the same height. If AB is equal to 6 centimeter, how long is CD? So we know that the area of the two connected rectangles can be added together, which will give us the total area, as long as the rectangles do not overlap. So here the rectangles does not overlap, so we can sum the area. So we can sum the area of the first two rectangles. So 12 plus 18 gives us 30 centimeter. Now we know if this is the length, this is length of this rectangle, and this is width. So we know the length into width is equal to 30 centimeter. So length is 6 into width is equal to 30 centimeter. Now we divide by 6 on both sides. So we divide by 6 on both sides. So we get 1 in here. Width is equal to 5 centimeter. So width is 5 centimeter. We have the area. Now we have this area and 18. So we add 18 plus 22 and get 22 and get 40 centimeter. We know the width. We need to determine the length. So again we'll do length into width is equal to 40 centimeter. We need to determine length. Width is 5 is equal to 40 centimeter. We divide by 5 on both sides. 1 and here we get 8. So length we get is 8 centimeter. So our answer is option C, 8 centimeter. If you want to help me continue making these helpful videos, please subscribe and share with others. It really encourages me to make more videos. Now let us move to the next problem. Problem 16. Ronja had 4 white tokens and Vanja had 4 dark tokens. They played a game, taking turns to place one token at a time on top of one of the two piles of previously placed tokens. Ronja started first. Which of the configuration would not be possible to create? These are our options. Let's start with option A. So from question we know that Ronja has white token and Vanja has dark token. Let's start with option A. So by looking to this, we know that who placed which pieces. So here Ronja start first. So Ronja has done this. Then Wanza placed the dark place. Then Ronza may have placed here. Wanza dark place. Then Ronza may have placed here. Then Wanza placed this one. Ronza place here, and then so this is possible solution. So it's not, so option A is not. Let's look into option B. So Ronza starts first. Wanza put the dark piece, Ronza put the white piece, and then Wanza put the dark piece, Ronza put it here, Wanza put the dark piece, Ronza put the white, and Wanza put the dark piece. So all configuration is possible. So this is not our answer. Let's move to option C. So Ronza put here, Wanza put here, Ronza put it here, Wanza put here, Ronza put it again on top of it, Wanza put here, and then Ronza put here, and Wanza put here. So again, this is possible. So this is not our option. Option D. So Ronza starts here, Wanza put here, then Ronza put it here, Wanza put it here, and then Ronza put again here, Wanza put it here, Ronza put here, and Wanza. So this is also possible. So this is not our answer. We eliminate it. Let's move on to option E. So we start with Ronza. Ronza put his first token here. Wanza put it here. Ronza again put it here. Wanza put it here. And that is not possible because it's Ronza's turn and both are black. So option E is our answer. Problem 17. My little brother has a 4-digit bike lock with the digits 0 to 9 on each part of the lock as shown. He started on the correct combination and turned each part of the same amount in the same direction, and now the lock shows the combination 6348. Which of the following cannot be the correct combination of my brother's lock? So we know the digits are from 0 to 9, and we have 4 segment 1, 2, 3 and 4 segments on all the locks. So here also we have 1, 2, 3, 4 segments. If we will expand these numbers for each segment and it starts from 0 to 9, it will look like this. So we have, for first segment we have 0, 1 to 9. For second we have 0 to 9. Third we have 0 to 9, and fourth we have 0 to 9. And what number is visible is 6, 3, 4 and 8. Now let us go through each option and see which one is not possible. So we have here 8, 5, 6, 0. So going through the first segment, we see 8 here, which is one number after the original number. So we will go here and say 5, 6 and 9. After 9 it is 0. So we have 8, 5, 6, 0. So this is possible. So this is not our answer. Let's clear our screen. Second option, option B. So we have first combination 3. So 2 numbers before the original. So we got here 0. 4 we got 1. And 8 we got 2 number here. So 5. So it should be 3, 0, 1, 5. This is exactly what it is. So this is not our answer. So option B is not our answer. Clear screen. We have 4 as the first segment. This is one number before the original. So we have 1, we have 2, and then we have 6. So it should be 4, 1, 2, 6. This could be our answer. Let's try option D. So option D, it is 1, it is before 1, 2, 3, 4. So it is 4 numbers before the original. So we'll count 1, 2, 3 and 4. So the fifth one. Now 4 number before 1, 2, 3, 4 and the fifth one. 1, 2, 3, 4 and the fifth one. So it should be 1, 8, 9, 3. This is correct. So this is not our answer. Let's try option E. It is 0. That is 1, 2, 3, 4, 5. So it is 5 numbers before the original. So from the second segment, so this is the sixth one. Third segment, 2, 3, 4, 8. 1, 2, 3, 4, 5 and last segment 2. So we have 0, 7, 8, 2. This is also correct. So our answer is option C. Problem 18. There is a single train track between point X and Y. This is the point X and Y. A train company wants one train to leave from X and one train to leave from Y at the same time daily. Moving with constant speed, it takes 180 minutes for a train to make a trip from X to Y and 60 minutes from Y to X. They want to build a double track. This is the double track. To avoid a crash, where should the double track be? These are our options. Since the trains are leaving at the same time, we have to make sure they don't crash into each other. To do this, we want to build a double track in the middle of the road, where both trains can safely pass each other. The train from Y is faster, so it will reach the middle of the track quicker. If the train from X takes 180 minutes and the train from Y takes only 60 minutes, let's add the minutes here. What is the ratio of the speed between X and Y? So the ratio of the speed can be determined by 180 divided by 60. So X to Y and Y to X, and that is 3 times. So the train from Y to X is 3 times faster than the train from X to Y. If a train from Y travels 3 spots, so it is 1, 2, 3. The train from X to Y covers 1. That means when the train Y reaches to one point, train X has traveled 1/3 of 1. When it reaches to 2 points, train X has reached another 1/3. When a train from Y reaches to third point, it reaches to this point. Now when the train reaches here for another stop, that means the train from X supposed to be here and they might collide. So we need a track here so that the train passes through this direction and the train from X reaches to 1/3 of it. So this means option A cannot be possible. Option B is our answer. Problem 19. What is the smallest number of shaded squares that can be added to the diagram to create a design of 6 by 6 with 4 lines of symmetry? This is our diagram. We have to create a 4 lines of symmetry. These are our options. Let us first understand what is 4 lines of symmetry means. So 4 line of symmetry means if a line is being drawn on this figure horizontally, shape made in here, this area and this area should be same. If a line is being drawn vertically, then the shape on this area and this area should be same. If a line is drawn symmetrically diagonally, that is top left to bottom right, the shape that comprises in this area should be same as in this area. If a line is being drawn symmetrical anti-diagonally, that is from top right to bottom left, then the shape covered in this area should be same as in this area. Let us draw this 4 line of symmetry on this shape. So from 4 line of symmetry, we understand that there should be a shape same as here. So there should be here in this coordinate. From this coordinate, we understand it should be in here. From this coordinate, we understand it should be in here. From here, from on this symmetry line, it should be coming in this direction. And this one here. Similarly, shape should be drawn here and a shape to be drawn here. So in total, it should look like this. Now let us count the green shapes in here. So here we have total squares 4, 4, 4, 4, 4, and 4. So how many squares we have in total? 6 times 4 gives us 24. But we have already counted these squares. So these are the 3 squares. So we'll take out 3 squares. So 24 minus 3 gives us 21. And our answer is option E, 21. Problem 20. 3 pirates were asked how many coins and how many diamonds their friend Greybird had. Each of the 3 pirates answered one of the questions truthfully and the other question falsely. Their answers are written on the piece of paper pictured. So these are the answers. What is the total number of coins and diamonds that Greybird has? These are our options. So we know that the 3 pirates answered one of the questions truthfully and other questions falsely. So from here we know that 2 pirates says 7 coins. So if we say that 7 coins were false, then both 4 diamonds and 7 diamonds would have to be true. But Greybird can't have 2 different diamonds counts. So this means 7 is true. Now we test which diamond counts fits. So we know that 4 and 7 diamonds could not be possible because 7 is a true statement. So only 6 diamonds left then. So this means only 6 diamonds work. And each pirate has 1 true and 1 false part. So we have 7 coins plus 6 diamonds. Now the question says, what is the total number of coins and diamonds that Greybird has? 7 plus 6 gives us 13. So our answer is option C, 13. So this is our answer. So that's it for today. If you enjoyed this, make sure to subscribe and I will see you in part C of 2021 of Math Kangaroo for grade 5 and 6. Keep up the great work. Thank you. Bye.